Welcome to Progress Rail. We're based at Sandy Acre in Nottingham and we're the main manufacturer of switches and crossings for the rail industry. Fabricated switches and crossings are manufactured from normal pieces of rail with a series of machining operations from a variation of milling, turning, planing, welding and final assembly to make bespoke products for network rail.
What you're going to see today is the manufacturing process from start to finish. You're going to see the rails being cut, machined, milled, welded, bolted together and then dispatched. The first part of the process is cutting the rails to length on the CNC saw machine.
CNC means computer numeric controlled, meaning the sawmill is pre-programmed to follow an individual switch or crossing design.
I will upload that program from the drawing office, and this machine will drill and cut to whatever is required. It is a big bit of kit, but when you consider some of the rails that it's handling are 120 foot long, you do need a big bit of kit. I've got 16 different size drills you can choose from. I've got a tungsten carbide saw blade which cuts through very easily.
Once the rails have been sawed, drilled and tagged, they go to be machined into completely new shapes. Planing gradually slices rails down to narrow the profile to create sections such as switchblades.
Oh, this is a planing machine. Well, it's important to get it straight or follow the line, the curve of the bender that's in the rail. Once we're going to get that, it'll give us a true running line for when they assemble it afterwards.
While the planing machine slices down the original rail in long sweeps, milling machines grind down other parts of the same rail to more complex profiles, allowing it to fit into other parts of the switch and crossing layout.
It's an Elga mill milling machine. There's things that's special about this machine. It's got an indexing head that can work on any angle. Change the head over, it can work any angle that comes along. From vertical, horizontal, 45 degrees, any sort of angle that needs to be like.
In another area of the workshop, a part welded crossing is being prepared. Two long sections of rail have been machined into shape. An insert bar is placed between them to create adequate width, and they are then raised into the vertical to be welded together.
It's an electroslag welding machine. The welding heat is derived from the electrical resistance of the slag bath to the amperage that we're using.
The welding takes 3 hours to complete, but it's important that the weld is strong enough on this high-load component. Once joined and cooled, the V-crossing component is machined to the finished profile. The V will then need to be joined to a longer rail called a leg. The process used is called flash butt welding.
When you switch a light switch on a tone and the two connectors come together, obviously they heat up. This is exactly the same process, very simple. Pass electric current through these two copper plates, into these two copper plates, very high current. It melts the end of this rail by touching them together, and then when they become fluid enough, this side has got a big ram on it, butts it up against that side, and they become one rail. And they've been pushed together, and now it's one solid piece of rail. This is a much stronger weld than the thermite weld because you're actually melting the ends of the rail and they're actually forming the material and making one piece of rail.
At the end of the machining processes, the switch and crossing component parts, collated, checked and tagged, are ready to be sent off to be assembled.
When you see the components being made at Sandy Acre, quite hard to understand what they're for. It's only when they've been assembled at our site at Beeson it starts to make sense. All the components, i.e. the jigsaw pieces, come to this site and we put them together to prove that the switches and crossings go together correctly. Once we've proven they go together correctly, we will then dispatch them to site. This is one of our finished products ready for dispatch. These switches are powered by iDrive units in the middle of the bearers. Judging by the length of these switches, these will be used in high-speed rail. Some of the components we use are cast chairs, which are made at a Sandaker site. You've got screws that are screwed to the concrete bearers. You've got pads to stop vibration. You've got a clip, which is called an E-clip, which has got an insulation to stop signal failure. This is a switch rail. Look at its profile. This started off life as a normal rail. This was manufactured, milled, bent in position to site at Sandaker. It's quite an achievement how the rail starts off life like this and finished with a profile like this. This is not going to be disassembled. This is a modular unit. This will be loaded by cranes onto a tilting train and sent to site, which in this case is Scotland. This is Network Rail's new modular train. This allows us to ship switches and crossings in modular form. This is a genius idea. Before this, we used to have to dismantle the switches and crossings we'd assembled on the yard and send them straight to site for reassembly. We don't need to do this anymore. Instead, we load the pre-assembled switches and crossings to the train. We tilt the train to allow it through tunnels and stations. This is delivered straight to site, offloaded, saving time and money.
We're very proud of the work we do here. The manufacturing unit has been going for over 50 years. There's a lot of skill, dedication, and we pride ourselves on the quality of work that we turn out.